Hi everyone, this is Muhammad Abdul Qadir. I am a graduate student at the University of Vermont. Today I will gonna present my poster, which is about shrinking chitosan fibers to improve the long-term concrete durability. In the introduction, we know that concrete is the most used construction material in the world, and it's one of the most important materials in today's world. Concrete has many different benefits, mainly, for example, its compressive strength, which is pretty high. But in the same time, concrete has many imperfections. For example, its low tensile strength, its low durability. So to overcome these imperfections, usually we are reinforcing concrete with another material. Usually have a material that has a high tensile strength. For example, steel rebars and fibers. So fibers is one of the materials that are usually used to reinforce concrete to improve its tensile strength, to increase its durability, and the way that, or the mechanism that these fibers are usually working at is that they are helping to bridge the cracks and prevent them from expanding. In this research, we will use another type of fibers, which is chitosan fibers, and the chemistry of the chitin and ultimately the resultant chitosan is why chitosan fiber will shrink in high pH environment, like Portland cement concrete. So chitin has an acetyl group connected to a secondary amine group. When chitin is deacylated, the acetyl group is removed and the secondary amine group became a primary amine group. Chitosan is not soluble in water but soluble in acids. Dissolving chitosan into an acid has an effect of turning the primary amine group into ammonia group by reaction with the hydrogen ions in the acid. So what the main resource, or the primary resource to produce chitosan fiber is the seashells. So these seashells are grinded and then processed to result in this chitosan powder in the right image, and then this powder is going to be processed again in the lab to produce a chitosan fiber sheet, which is going to be cut using a scissor, a paper cut, a cutter, or any other way. And then these chitosan fibers are going to be added to the concrete to reinforce them and to shrink the concrete or the mix, to shrink the mix so it could increase the strength of the concrete, decrease the permeability and the voids inside the concrete, which will result in a higher tensile strength and, as a result, a higher durability. So this research is a continuation of another research that has been done by another UVM student, which is Dermot. So Dermot research, or Dermot used chitosan fiber to increase the tensile strength and the durability of the concrete, and the results were great results. So, for example, here are some of the results we have. The chitosan reinforced concrete showed increased durability. For example, the 1% weight chitosan concrete had a 540.5% greater durability factor than the control group. And after 300 freeze-thaw cycles, for example, the 2% chitosan fiber concrete was the only group with all its 5 specimens intact, and the control group failed faster than any other group. So here are some of very interesting results of the research that we have. as it is very clear. So we have here in the y-axis the relative length of the concrete specimens, and in the x-axis we have the number of freeze-thaw cycles. So the 0% or the control group has been failed at almost 150 cycles of freezing and thawing, with the fact that there was many or the chitosan fiber groups were able to survive even after 300 cycles of freezing and thawing. For example, we have here the 2% weight chitosan fiber active group and 1% weight chitosan active group, and the 0.24 active group. So maybe you can notice that there is two different types of groups here, passive and active. And what is the difference between them? It's very simple. The passive fibers were created by pre-shrinking active chitosan fibers in an alkaline solution, and then they were added to the concrete mix. So the results were very great, and they showed an increased durability of the concrete, and the active groups worked better than the passive groups. So as we can see here, we have here 3 groups that survived at 300 cycles of freezing and thawing, and all of these 3 groups are active groups. We have another active group here which is 0.5, but it lost almost or 80% of its length. So what are the planned work? So here I will gonna talk about the planned work. So 4 mixes will be tested, including a control mix without fibers, and 3 different mixes. One with the same size of the chitosan fibers that has been used in the previous research, a new group with smaller fibers, with a higher aspect ratio, and this is mainly to study the effect of both size and aspect ratio on the mechanical properties of concrete. A third group or a fourth group is an old chitosan fibers that we have from the previous research. So all these 4 mixes are going to be, or 4 different mixes are going to be poured using these 4 different types of chitosan fibers that we will prepare. So as I mentioned, the active groups worked in a much better way than the passive fibers in the previous research, and for this reason we will going to use only active fibers because of their better results in the previous tests. So what are the objectives of this research? The main objective of this research is to understanding the effect of both age and size of chitosan fibers on concrete, mainly the mechanical properties of concrete, and to decreasing crack width in the hardened concrete, which is very important mainly here in the New England area because of the extreme weather in the winter. So cracks are one of the very clear enemies of concrete in this area of the country. And third, to study the internal adhesion between the natural chitosan fiber and concrete mix, as it is very clear. So we want to study and to be sure to be sure if the adhesion between the chitosan fiber and concrete constituent materials is good or it's poor. And all these things are going to lead to an increased long-term durability of concrete. At the end, I want just to acknowledge the funding for this research, which is provided by the Transportation Infrastructure Durability Center and the University of Maine. And I want to thank my colleague Bismarck for helping me with the tests. Thank you for listening.